Hello and welcome. Today we're doing a question from LeetCode called edit distance. It's a medium. We're going to jump right into it. Given two strings, word 1 and word 2, return the minimum number of operations required to convert word 1 into word 2. You have the following three operations permitted on a word. You can insert a character, delete a character, or replace a character. Example 1, we want to go from horse into Ross, ROS. So here the minimum number of operations required are 3. We're going to replace H with R, so we go from horse to Rorse. Remove that middle R, so Rorse to Rose. And then remove that last E, so we go from Rose to Ross. And our minimum edit distance here is 3. Example 2, we want to go from intention to execution. Here, the edit distance is going to be 5. We go from intention to inention, removing the T. Then inention to enention, replace I with E, then enention to extension, replace N with X. Then we go from extension to exection, replace N with C. And finally, execution to execution by inserting the U. So there were a total number of 5 operations. And we have some constraints over here. Word 1 and word 2 consist of lowercase English letters. We want to convert word 1 into word 2, either by inserting character, deleting character, or replacing a character. Now, how do we do this? If we have no idea how to approach a problem, we always want to start off with examples. And if we're also unsure of what examples to use, we're always going to start off small, start with some base cases and work our way up. So for our first example, let's start off very simple. We just want to go from the empty string into empty string. So word 1 is the empty string and word 2 is also the empty string. What is the edit distance here? Well, here it's the same exact string, so there are going to be 0 operations needed. So our edit distance here is 0. Now, what if we wanted to go from the empty string into the string of A, B? What is the edit distance here? Well, we would be inserting A and inserting B because there's really nothing to delete or replace in word 1. So our edit distance is just going to be the length of AB. So that's going to be 2. And this can work the other way too, right? Converting word 1 into word 2 is going to be edit distance of 2. And converting word 2 into word 1 is always going to be the same exact edit distance. We just do the exact opposite. Here we would have inserted A and B to get from the empty string into A and B. But if we had AB, and let me write this out actually, if we had AB as our input string and we wanted to go into the empty string, we would just delete A and also delete B. So we would have the same edit distance of 2. So converting word 1 into word 2 or 2 into 1 is going to be the same exact edit distance. Now, what if we wanted to convert AB into BA? What is the edit distance here? Again, we can insert, delete, or replace a character. Well, if you have AB, we could just delete the A and then insert it to get BA. So that would be an edit distance of 2. Or something else we could do is replace each character. We could replace A with B and B with A, and we still get an edit distance of 2. This means there's more than one way to get the minimum edit distance. We just want to find the minimum number of operations required, not the way in which we did it. So now what if we wanted to convert ABS into BAS? All we're doing is taking our previous word 1 and word 2 and appending S to the end. So what's our edit distance going to be now? It's going to be unchanged. It's still going to be 2. And why is that, right? We're adding the same exact character to both our strings. So essentially what we're doing is finding the minimum edit distance between AB and BA, which was 2. And since we're adding the same exact character, since the characters we're comparing are equal, the edit distance between the same character, between the same strings, is going to be 0. We saw that over here, right? The same word 1 into word 2 is an edit distance of 0. Adding S to both is going to be an edit distance of 0. So we just retain what our previous edit distance was in our previous substring. So AB into BA is 2. And since we're adding the same characters, comparing that same S, it's still going to be 2. Now, finally, our last example, say we want to go from ABC to BAD. Here, our characters are different. We still have AB and BA. We know the minimum edit distance between these two strings is 2, but now we're adding C and D. They're not the same character, so we can't just reuse our previous edit distance. We want to see whether it's better to insert, delete, or replace a character, which means we're going to have to try out all 3 possibilities to figure out our final minimum edit distance for the entire 2 strings. Now, worst case scenario, what would that be? We can always convert word 1 into word 2. We could just delete every single character and insert every single one of our own. We just want to see if we can do something better than that, right? Which means we're actually going to be building up our solution. We're going to check character by character, making combinations of every single character in both strings. So we're going to be using dynamic programming to solve this. And in order to do this, since we are making combinations, we're going to initialize a 2D array. So I have my 2D array over here. Word 1 is along this horizontal over here. We have A, B, C. And word 2 is along this vertical B, A, D. I have all the characters that I'm going to take from word 1 up here and word 2 over here. So I have 0 characters, which would be the empty string. That first character, just A. Second character, B. Third, C. And here again, start with 0, empty string, then B, then A. And finally, all 3 characters, which would be D. So we want to go from word 1 into word 2. If we're starting with the empty string and empty string, what's the edit distance? That's just going to be 0, right? Nothing's really required. Now, what if we want to go from A to the empty string? We're using 1 character from word 1 and 0 from word 2. How do we do that? Well, we saw that over here, right? We want to go from some string to the empty string. We just keep deleting. So here we're going to delete 1A, which means the edit distance is going to be 1. And once we come across our second character, we're now going to have to delete 2 characters. So the edit distance is going to be 3. And once we get to 3, edit distance is 3. We have to delete 3 characters. So we go from ABC to the empty string. Now, what if we want to go from the empty string into B? We're converting word 1 into word 2. And right now, word 1 is just the empty string. And word 2 is going to be 1 character of B. If we want to go from the empty string into anything, we have to insert characters, right? So if we have the empty string, we're going to be inserting 1B. So the edit distance would be 1. And again, over here, we're going from the empty string into BA, 2 characters of word 2. So the edit distance is now 2. And over here, once we get to D, edit distance is going to be 3. Every time we move down, we're inserting a character. And every time we move to the right, we're going to be deleting a character. So now that we have our base cases established, let's start off with 1 character from each word. We want to convert A into B. So we're looking at this cell over here, right? How do we do this? We know how to go from the empty string into the empty string. We know how to go from A into the empty string. We know how to go from the empty string into B. How do we go from A into B? So now we want to check our 3 operations: insertion, deletion, or replacement. We're going to try all of them and see what the best case scenario is. So if we wanted to insert a character, we know we're moving down to insert, right? If we had the empty string, we want to go from empty to B. We're going down, we're inserting a character. So we go check the cell above us and add 1 to that. So here, if we want to insert a character, we check the cell above us and add 1 to that. So that's going to be 2. What this means is A to the empty string was an edit distance of 1. And we're right now at the empty string and we want to go to B. So we're inserting B into this empty string and getting an edit distance of 2. Now, what if we wanted to delete? And for that, we're moving to the right. So over here, we know how to go from the empty string into B. So right now we have B. And now once we consider A, we need to delete that character to finally turn A into B, right? Because right now we have B. Once we also consider an A, we need to go ahead and delete that to finally turn A into B. So the edit distance for that is going to be whatever's to the left of us plus 1. So that's also going to be 2. Right now, our best case scenario is an edit distance of 2, either by insertion or deletion. So if we want to replace a character, we're not going to consider either new character that we are checking right now. So A or B. We want to check what we had before that. So before 1, 1, we had 0, 0, because we can't consider this A or this B. So we look at this cell over here. We had the empty string into the empty string. That was an edit distance of 0. And we're just going to add 1 to that because we're substituting, right? We're going from A to B. So we look at the cell to the top left of us and add 1 to that. So that's going to be 1. And that's lower than the edit distance we have so far. So we're going to go ahead and replace that to use the minimum. So the best edit distance to convert A into B is 1, and that's going to be done through replacement. And this is the logic we want to use to go ahead and fill out this entire DP array. And at the end over here, we're going to get to this corner, which is going to represent our answer. Because this means we're converting all of ABC into BAD, and we're going to know the best way to do that. So just to fill this out and explain this a little bit further, we want to convert AB into B. We can either delete a character, so we go to the left of us, add 1, insert a character, go above us, add 1, or replace a character, go to the diagonal and add 1. But we only do that if the characters are different. Here, the characters are the same. So we have B and B. The best case scenario here would be to not consider these characters at all. So we don't consider B and B at all. We consider what we had before that because we know that's going to be the same exact edit distance, right? We're just adding the same character to the end. When we had ABS and BAS, we just split it up. We didn't look at S and S. We just looked at the substrings before that. So AB into BA, and we reused that. So here we're doing the same thing. We're just going to reuse what we had to go from A into the empty string. And that's going to be the same as going from AB into just B. So we're just going to copy over what we have in the top left and bring it over. So this is going to be an edit distance of 1. So to convert AB into B, all we really have to do is delete A, right? B and B are going to be the same, and that makes sense. So the edit distance here is just 1. So now we're going to consider 3 characters from word 1. We want to convert ABC into B. So we're going to check these new characters that we're now comparing, C and B. Since they're not equal, we want to check all 3 possibilities and take the best one. So we're going to look above us, to the left of us, and to the top left of us. Take the minimum and add 1 to that. So here the minimum is going to be 1. We're just adding 1 to that, and now we know the edit distance to go from ABC to B. That's going to be an edit distance of 2. And we know we moved to the right, right? We went from to the left of us and now added 1 to that. We're moving right, which means we're deleting this new character. So in order to convert ABC into B, we know we have to delete this C. So that's an edit distance of 1. So now we want to convert AB into B, and we know how to do that. We just want to look at converting A into the empty string. That's a deletion. That's just going to be an edit distance of 1. So 1 plus 1 gives us a total edit distance of 2 to convert ABC into B. And now filling out the rest of the table super quickly, we are now at A and A. These are the same characters, so all we need to do is go to the top left of us and copy that over. So this is going to be 1. Now moving over here, we have AB. These aren't equal. Check the minimum over here between these 3 values and add 1 to that. Doesn't matter which way we take. Again, there could be multiple possible ways as we see over here. So we're just adding 2 over here. Then we get to C and A, different characters. Take the minimum, add 1. That's going to be 2. Over here, we go A and D. They're not the same character. Take the minimum, which is 1, add 1 to that. We get an edit distance of 2 to convert A into BAD. And feel free to pause the video and take out a paper or pen if you want to see every single conversion for every single combination. But moving on, we're now going to convert AB into BAD. In order to do that, we're taking the minimum, which is the top left, which means we're going to be substituting B into D. So we're taking that top left, it's the minimum, adding 1 to that to get a total of 2. And finally, ABC into BAD. C and D aren't equal. We want to take the minimum. They're all the same here, doesn't matter. So our total edit distance is 3. So this is how to solve the edit distance problem. We're building up, right? We're going to initialize a 2D array with the length of word plus 1 and length of word 2 plus 1. Initialize the first row and first column. And then just loop through every single index, every single character combinations between word and word 2. And check if the indices of the characters we're on are equal. If they are, we just take that top left and paste it into our own cell. If they're not, we want to check above to the left and top left of us to check insertion, deletion, or replacement and see what the best approach is. Once we fill everything out, and we'll know the minimum edit distance required to convert the entirety of word 1 into word 2. So let's go ahead and code this up and then run through a super quick example. Okay, to code this up, first thing we want to do is initialize our DP array. We're just going to fill it up with all zeros. So DP is going to be 0 for I in range, length of word 1 plus 1. And we're going plus 1 because if we did the exact length, it would be 1, 2, 3. But we also want to take into account having no character, so we're going to add an extra index for that. So right now we just defined zeros for all of word 1, and we want to do this for every single character in word 2, make that many rows. So we're going to add another array over here. We're going to do all of this for J in range, length, word 2 plus 1. So now that we have a DP array of all zeros, we want to go ahead and fill out that first row and first column. So for that first row, we're going to be looping through. So for I in range, length of word 1 plus 1, we're setting DP of 0, I to be I. So DP of 0, 0 is going to be 0. Then we go back in this for loop, I is now 1. DP of 0, 1 is going to be 1. Then we go back in the for loop, DP of 0, 2 is going to be 2, and so forth. And we want to do the same for our column. So for J in range, length of word 2 plus 1. And here we're going to do DP of J, 0. So for every single row and that 0th column of that row, we're going to set this equal to J. So at first it's going to be 0, 0, which we've already defined. And then after that, we go to 1, 0, which is going to be 1, then 2, 0, which is going to be 2, and 3, 0, which is going to be 3. So now that we have these defined, we want to loop through from 1, 1 onwards. So for J in range, 1 to length of word 2 plus 1, and for I in range 1, length of word 1 plus 1. So the first thing we start off is at 1, 1. we want to check if those characters at I and j are equal to each other. So if word 1 of I minus 1 equal to word 2 of j minus 1. So here we start off at 1, 1, right? We want to check word 1 of 1 minus 1. We want to check the 0th character of that string. The 0th character of word 1 is going to be A, and the 0th character of word 2 is going to be B, right? We inserted those extra indices in the beginning, which is why we want to do minus 1 over here. So right now we're going to be comparing word 1 of 0 and word 2 of index 0, so A and B. If they are equal, then we're going to be taking what's to the top left of us and just adding that to our own cell. So if that is true, dp of ji is going to equal dp of j minus 1 and I minus 1, what's to the top left of us. If that is not true, so else, we're going to check what the minimum is. Is it above us? Is it to the left of us? Is it to the top left of us? So dp of ji is going to be the minimum between all three. So dp of j I minus 1, dp of j minus 1, I, and dp of j minus 1, I minus 1. So between all three, we're taking the minimum and we're just adding 1 to that. And once we're through this entire for loop, all we have to do is return what's at the bottom over here. So we just return dp of j and I. So let's go ahead and submit this. And it is accepted. Now talking about space and time complexity. For time, we're going through every single character in word 1, and for every single character in word 1, we're going through every single character of word 2. So there are n characters in word 1 and m in word 2. The time complexity is going to be O of n times m. And same with space, right? We're making a 2D array of length of word 1 times length of word 2. So space is also going to be O of n times m. Now before leaving, let's just run through a super quick example just to come full circle and tie all of this together. Okay, say my input word is cart and I want to convert it into word 2, which is arc. So the first thing I'm going to do is initialize a DP array. So I'm going to start off with 0 and I'm going to add length of word 1 plus 1. So 5, I'm going to add 5 zeros as my first array. So 5 zeros over here, and I'm going to add this array for j in length of word 2 plus 1. So I'm going to add this array 4 times. So it's going to look something like this. We have 5 zeros and we have that array 4 times. Now I'm looping through length of word 1. I'm starting at 0, 0, and I'm assigning it to be that index I'm on. So now I go back in this for loop, I'm at 0, 1, I'm adding 1, go to 0, 2, adding 2, 0, 3, add 3, and 0, 4, add 4. And I do the same thing for the column. I'm ranging for length of word 2. So going from 0, 0, that's going to be 0, 1, 0 is 1, 2, 0 is 2, and 3, 0 is 3. Now I go into my main for loop. I start off at 1, 1. So j is going to be 1 and I is going to be 1. We're at this cell over here. We want to check word of I minus 1. So what is at index 1 minus 1? That's index 0. It's k. And word 2 of j minus 1. So index 0 over here. They're not equal, so we don't go in this if, we go in this else instead. So now we want to check j of I minus 1. So j is 1 and I is 1. We're checking 1, 0. We're checking over here, which is 1. And we're checking j minus 1 I. So that's going to be 0, 1. And we're checking j minus 1, I minus 1, which is 0. What's the minimum of all of that? That's 0. We're taking that minimum and adding 1. So now we have an edit distance of 1 at this cell. Now we go back in this for loop. We move I down to 2. And we make another check. Here, A and A are equal. All we do is take what's to the top left of our current cell. We take that 1 and we just add this in over here. We go back in this for loop, move I down. I is now 3. R and A are not equal, so we are in this else statement, and we want to check the minimum of all 3. The minimum is 1, we add 1 to that, and we get 2. Go back in the for loop, move I down. T and A aren't equal, so again, we take the minimum and add 1 to that, so that's going to be 3. And now we're out of this for loop, and we go back into this for loop over here. So now J is at 2, and I is back at 1. So now we're looking at 2, 1 over here. K and R aren't equal, so we check left, up, and to the top left of us. The minimum is 1, so we add 1 plus 1 to dp of ji. So that's going to be 2. And we go back in the for loop, I is moved down. A and R are not equal. We take the minimum, add 1 to that, that's going to be 2. Move down, R and R, they are equal. So we're in this if condition over here, right? These two are equal. So we're setting dp of ji to be dp of j minus 1, I minus 1. It's going to be 1 over here. Going back in the for loop, R and T are not equal, so we're not in this if condition, we're in this else over here. We check to the left, above us, and to the top left of us. Here the minimum is 1, so we're taking that, adding 1 to that to get 2. So KART into AR, that edit distance is going to be 2. And we know there's a deletion involved because the minimum comes from the left of us. We moved right to get our minimum. So we're deleting this last t. And now to consider k and ARC, we go back in this for loop, j moves down, and I is back at 1. We check word 1 of I minus 0 and word 2 of j minus 1. K and c aren't equal, so we're in this else over here. And we want to calculate the minimum. So j of I minus 1, which is 3, j minus 1 of I, which is 2, or j minus 1, I minus 1, 2. Either way, we take the minimum, which is 2, and add 1 to that, which is 3. Move I down back in the for loop. A and C aren't equal, take the minimum, add 1, that's 3, move it down again. R and C are not equal, we take the minimum, and we add 1 to that. We're taking it from above us, which means we're inserting the letter C. So here, the minimum edit distance is 2. Move this down. Here, T and C aren't equal, so we take what's to the top left of us, that's the minimum, and add 1 to that, which means we're replacing T with C. So here, the edit distance is 2. So it takes a total edit distance of 2 to go from KART into ARC. And just to sort of see what we did for that, we can retrace our steps, right? To get to 2, we took the minimum, which was 1 over here, which means we're replacing T with C, which means now we want to consider KAR and AR. What's the minimum to go from KAR to AR? Well, we're checking this cell over here. We got the minimum from over here since R and R were equal, which means we didn't do anything to these R's. We just looked at the conversion needed to go from KA to A. So in order to do that, we keep A as it was and look at the edit distance to go from K into the empty string, and we get that by deleting K and substituting T for C to convert KART into ARC. So we just went ahead and solved edit distance. If you have any questions whatsoever, of course, let me know down below. I will answer all of them. If this video was helpful, like, comment, and subscribe. It really supports the channel. And as always, I will see you in the next one.